Question: have you ever heard the term involution? No? Didn't think so. Well, I am pleased to let you know, and super appreciative that we have George Costanza here to explain it to us in simple terms.
Well, I just got back from swimming in the pool, and the water was cold.
You mean shrinkage?
Yes!
And the organ he's talking about is the least of our longevity concerns. Here's why. Yo, what is up? Welcome back to another week of How to Health. My name is Kevin. I run liftandbalance.com, where we take aim at all things health and longevity and do it in an odd, weird, interesting, and highly sarcastic way. Today, we are talking about shrinkage, but not just the shrinkage of any organ or the one that you're thinking about. We're diving into the shrinkage of the gland, which modulates the function and efficiency of our police force within, or the family of cells when working properly keep the biological peace, otherwise known as our immune system. The organ we are once again exploring is the thymus, because we've got some super interesting, potentially groundbreaking, hot off the scientific press, new data shedding light on the mystery of why this shrinkage actually occurs, or what is actually happening to drive it. And if we've figured out anything as a species about reverse engineering a problem, uncovering what is mechanistically going wrong is quite helpful. So that's exactly what we're gonna review today, connecting these new insights with what it potentially means for our health and longevity, and finishing up this powwow, as we always do, talking about what we can do. Because come on, no one wants to end up in the situation Costanza was in. So to begin, let's start with a quick reminder on why this small, upside-down, pear fig, butterfly-looking organ, which lies in the center of our upper chest, is so important. And I say remind because we recently did a deep dive into the function and importance of this organ in this video here. So if you want to truly gasp in horrific amazement, I suggest you check out that video, which will be linked in the show notes below. But for now, here's the Reader's Digest version. As alluded to, the thymus's primary function is to develop and educate the cells of our adaptive immune system, specifically T cells, or the part of the immune system which is precise and specific in its response. And to give you a little analogy, think of these T cells as your body's special forces division, waiting to receive intel from the innate immune system, or your first-line defenses, and ramping up millions of specialized immune assassins to target and attack a specific threat when it does, like a virus or bacterium. Pretty dope, right? So it is here in the thymus where every T cell you have ever had is trained, being individually prepped to identify basically every pathogen we may ever face. Again, we go through the inner workings of how this training actually happens in the aforementioned video. And it's crazy cool, so check it out. Long story short, if this training goes wrong or stops altogether, it poses quite the predicament for our body, either because it sets the immune system up to attack the wrong thing, like our own cells, a condition known as autoimmunity, which is becoming a bigger and bigger problem in modern society, or makes us ill-prepared to detect and fight off real pathogens, which is obviously an issue. So again, this is why proper thymus function is kind of important, which makes this next thing I'm about to tell you super not cool for longevity school. So buckle up. This critical immune organ begins its steady and consistent decline very early in life. First, slowly losing its mass and function little by little throughout childhood, to the point where it's about half of its original mass by the age of 25. And by the time the average person is 70, it's basically gone, being replaced by a little blob of fat tissue. Gone with it, many of the aforementioned benefits it brings to the table. This right here is thought to be one of the many reasons that immunosenescence, or the dysregulation of the immune system, gradually rises as the average person on this beautiful floating rock accumulates chronological years. And with it, an internal environment primed for an increased prevalence of cellular dysfunction and ultimately disease. Not cool, I know. But the question remains, what's actually happening? What's going on to drive this critical gland to deteriorate exponentially faster than all of its peers? A question that up until this point there has been no remotely good answer for, but luckily one that this new study decided to take on. Let's see what they found. Researchers out of the Walter and Eliza Hall Institute used state-of-the-art dynamic imaging and animal models to investigate why this key immune organ shrinks and loses its function as we get older. And in doing so, they uncovered two new types of cells which cause the thymus to lose its function. Cells which only conveniently appear in the defective thymuses of older mice and humans. They coined these cells age-associated thymic epithelial cells, and observed that they form clusters around T-cell growth areas, impairing the organ's ability to train and mature these important immune cells. Damn. However, this dysfunctional story doesn't stop there. These clusters of chaos ultimately were observed to scar the organ, preventing it from doing what so many other organs in the body do: restore and regenerate itself after damage. Doing this specifically by impairing a critical pathway called FOXN1. Thus, they observed, right on cue, as mice accumulated chronological years on this beautiful floating rock, so did they accumulate more of these problematic clusters, further inhibiting thymic function and regeneration signaling, and setting up the expected outcome of thymic decline and deterioration. Chillingly interesting, right? And I bet you're wondering, because I certainly was, why? Why exactly does this happen? And here is where I wish I had a good answer for you, because we're still not completely sure. However, two interesting tidbits from this research stood out. First, this deterioration seemed to be amplified and accelerated by routine insults such as stress and infection. And second, change in the surrounding microenvironment seemed to play a role too, with researchers observing that impaired mitochondrial function, proteostasis, along with an increase in inflammation and cellular senescence also exacerbated the situation. You don't say. Now, keeping in mind that the bulk of this data is coming from a mouse model, and that brings along all of the mice are not humans disclaimers.
Of course.
This is a big potential step forward in understanding how and why the thymus loses its way so early in life, and why, unlike so many other cells in our body, it does not just regenerate and keep chugging along. That being said, as you can imagine, much more research is needed here. But I have a feeling that this data just laid the foundation for a rapid acceleration of knowledge and potential therapies that may be able to tackle one of the hallmarks of aging, an increasingly dysfunctional immune system, which is pretty damn cool. But as all of that is being worked out over the next few decades, I can't help but ponder, is there anything we can do today? Being the optimist I am, of course. Let's talk about them. And the way I think about this is twofold. First, how do we delay the inevitable and preserve thymic function? And second, how do we limit stress and dysfunction in the surrounding micro and macro environment? Easy, right? Well, I've got some good and bad news. Starting with the not so great. Currently, there is no intervention that's shown to directly regenerate thymic function or mass. Yeah. However, there are in fact a whole bunch of ways to improve cellular function, thus improve bodily efficiency, and as a likely but unconfirmed byproduct indirectly influence thymic function in a positive way. You like those scientific gymnastics right there? Yeah. So we may have a few workarounds. And although, as we speak, researchers are exploring various avenues to improve and regenerate the thymus, including by modulating thymic hormones and leveraging stem cell therapies, both of which we discussed in that previous video, cellular modulation through lifestyle certainly seems to be the best current strategy, working its magic primarily through its mechanisms of supporting the cellular function of the immune system. Levers to pull here include activities such as real whole food eating, as a diet rich in vitamins, minerals, and antioxidants support overall immune health, with nutrients such as vitamin A, C, zinc, and selenium being vital for its function. Regular exercise and high quality sleep have also been documented as powerful immune boosters, as movement helps stimulate and tune it, and sleep plays an essential role in its recovery and regeneration. Oh, and might I add, what you don't do actually matters a lot too, as the less you live with the health of your pretty cool meat suit in mind, and instead succumb to the modern Western societal norms way of living, you know, the one of ultra-processed 24/7 eating, extreme sedentary behavior, chronic non-stop stress, deprived disaligned sleep, and lack of nature, the more cellular dysfunction you're likely going to be brewing on the inside. And as mentioned before, this will probably only accelerate that thymic decline. Multiply that with the well-documented effects of how chronic stress weakens and impairs the immune system, being tightly associated with rogue activity, aka chronic inflammation, and you can begin to see how this modern equation begins to add up to more dysfunction, disease, and morbidity faster and faster each decade. So although we may not have an official way to restore and regenerate thymic function yet, there are still ways to sway your odds, likelihood, and probability of a long, healthy life ever in your favor. Once again, coming down to whether or not you make the intentional decision to own your health. And who knows, if you do, you may even be able to avoid the undesired shrinkage, and instead shrink your rate of aging and morbidity. A much better thing to shrink. Ask George. He'll tell you.